Hello everyone, welcome back to the LeetCode plus DSS series. Today we are solving LeetCode 704 binary search. This is one of the most important algorithm for coding interview because it reduces the searching space by half in every single step and give us a super efficient O of log n solution. We will understand the intuitive behind binary search, code a optimal solution in C++, then do a quick dry run to show exactly how it works. So let's get started. So in this problem, we are given a sorted array and a targeted number. Our task is to return the index of that target number in the array if it is exist. Otherwise, return -1. Here the important thing is the array is already sorted. And whenever you see a sorted array in searching operation, there is a very high chance that the binary search can be used. Now, a brute force solution would simply be a linear search, where we check every possible element one by one. That would take O of n time complexity in worst case. But since the array is sorted, we can optimize this using binary search and reduce the time complexity to O of log n. Now let's understand the intuitive behind binary search. Instead of checking every element, binary search checks only middle element. If the middle element is equal to the target element, we found our answer. If the target number is greater than the middle element, then our answer should be in the right side. Or if the target number is smaller than middle element, then our answer should be in right side. So in every single step, binary search cut the search space by half, and that's why it is extremely efficient. So let's code the optimal solution. First, we initiate two pointers, I and j, and I in start and j in ending. J is ending index, so we put -1. And now let's while loop until I is less than equal to j. Let's take a variable mid, which is equal to I plus j divided by 2. That is half of I plus j. So if nums of mid is less than the target, then I will then our answer is in the right side. So we increment I to mid plus 1. And else if the nums of mid is greater than the target value, then the target value must be in the right side. So we put j equal to mid -1. Else nums of mid is equal to target. So we return the targeted mid index. And if loop ends, that means target does not exist. So we will return -1 at last. In this line, we calculate the middle index by I plus j divided by 2. And now we compare the mid element with target element in this code. First, compare that if the mid element is less than target, then then our answer must be in the right side. So we move our starting index into mid plus 1. Else, if the nums of mid is greater than the target element, then the target element must be in the right side. So we move j index to mid -1. Otherwise, we found the target, so we simply return mid. And if the loops end, that means the target number is not in the array, so we return -1. So now let's do dry run of this code for this array and target value. At first step, our I is 0 and our j is the size of an array is 6, so our j becomes 6 minus 1, that is 5. Since 0 is less than or equal to 5, this loop will be run. In this step, the mid become 0 plus 5 divided by 2, that is 2.5. Since we are in C++, an integer can float the value, so the mid becomes 2. So nums of 2, that is 3, is less than 9. So this if condition is run, and our I becomes mid plus 1, that is 2 plus 1, that is 3. Since 3 is less than or equal to 5, so the loop runs again, and the mid value is will become 5 plus 3, that is 8 divided by 2, 4. So nums of 4 is 9. So this else condition run and 4 will be written. Since binary search remove remaining half elements in every step, the time complexity become O of log n, and we use only few variables, so the space complexity is O of 1. And that's the solution of LeetCode 704 binary search. This is one of the most fundamental algorithm in programming, so make sure to fully understand the intuitive behind binary search. The full LeetCode solution link is in the description box if you want to check it out yourself. And I will see you in the next video. Thank you.